Hello students, in this video we will study about the Wheatstone bridge. Wheatstone bridge is basically an arrangement of four resistors which are arranged like this. Say you have four resistors P, Q, R and S, and they are connected across a battery in this manner. Now, what this Wheatstone bridge principle says is that if the ratio of the resistances P upon Q equals to R upon S, then if I connect these two terminals, and over here if a galvanometer is connected, then the galvanometer will not show any deflection. Now, how we can prove this? Now, in order to prove this, we will use the Kirchhoff's law. Now, before we use the Kirchhoff's law, let's do the current distribution in this entire circuit. Now, let's say this terminal is terminal A, this is B, this is C, and this is D. Now, if we are saying that between the terminals B and D, no current is flowing, this also implies that VB should be equal to VD. If the potential difference between the points B and D is 0, then no current will flow between these two terminals. Now, first of all, in order to prove this, we'll do the current distribution. Now, let's say the battery releases I current. Over here, the current gets split into two parts. One is I1, another is I2. Now, say in this branch, if IG current flows, then in this branch BC, the current which will be flowing is I1 minus IG. And in the branch DC, the current which will flow will be I2 plus IG. Now, consider a loop A, B, D, A. Now, in this loop, if I apply the Kirchhoff's principle, now what it would be? Now, say if I go in a clockwise direction, then I can write this I1 into P plus small ig into capital G. Say capital G is the resistance of the galvanometer, minus I2 into R will be equal to 0. Why I have chosen the minus I2 R over here? Because we are going against the direction of the current. As you can see, the current is going from A to D and we are moving from D to A. Now, let's say this is equation number 1. Similarly, when I consider loop BCDB, this loop, I can write the equation I1 minus IG into Q minus I2 plus IG into S minus small ig equals to 0. Say this is equation number 2. Now, say potential at point B equals to potential at point D. That means this implies Ig is 0. Now, what we are considering over here is we are considering that the current Ig is 0. Then the result which we should get over here is that P upon Q should be equal to R upon S. Now, let's see whether we get this or not. Now, if I consider that Ig equals to 0 and I rewrite this equation 1, this equation 1 will become I1P equals to I2R, as this Ig term will become 0. And if I take minus I2R on the other side, it will become plus I2R. Now, similarly, when I consider Ig equals to 0 for equation 2, I get this equation as I1Q. This Ig will become 0, and over here this Ig as well as this Ig will also become 0. Okay. this will become equals to I to S. Now here it will be Ij into G. Okay, I to S. Now this is equation 3, this is equation 4. Now if I divide equation 3 and equation 4, I get I1 cancels, I2 cancel, I get P upon Q equals to R upon S. And this is the result which we were expecting. Now one thing, just remember over here that if we interchange the position of this battery with the galvanometer, say instead of the galvanometer I put a battery over here, and instead of the battery I put a galvanometer over here, still the same condition will hold true, nothing will change.